Hello, everyone, and welcome to the pilot episode of the HQP Highlight Series. My name is Tetyana Levchenko, and I'm a research, training, and outreach coordinator at Carbon to Metal Coating Institute, or C2MCI. HQP Highlights initiative was created to showcase the exciting research and diverse experiences of highly qualified personnel across the C2MCI network, including graduate students, postdoctoral fellows, and other trainees working across macro, micro, and nano research teams of the Institute. Through these conversations, I hope to highlight not only scientific results, but also the people behind the research, their approaches, challenges, collaborations, and career journeys. Alongside the research communication, one of the goals of this series is to strengthen connections across the C2MCI community and support the professional development of our trainees. The HQP Highlight Series will primarily feature LinkedIn and social media spotlights, accompanied by selected video interviews, like this one. Thank you for joining us, and let's get started. Today, we're excited to speak with Hetvi Shah, a PhD student in Dr. Zheng's lab in the pharmaceutical sciences at the University of Toronto.
Thank you for having me today.
Our pleasure. So to get started, could you please share what you're currently working on at C2MCI?
Of course, so I'm part of the nano team at the C2MCI, and my job is to take the Au13 clusters that are made by the chemists at Queen's University and across our collaborators and apply them for a biological application for treating cancer. So that can be using them for enhancing radiosensitization therapies or enhancing photodynamic therapies. So it's quite exciting to be working with them.
Sounds fantastic. So what's first attracted you to this field of research?
Wow, that's a deep question. So I've been part of this, I've been part of this journey for a very long time. And I think the main driving force for me has been to really have some form of impactful research, may that be in the field of cancer or before it was in the field of metabolic studies. And so it's really to just try to improve the global health of patients across the world. If that means improving cancer outcomes by working with gold nanoclusters, then it's just exciting to be a part of that. And it just gives me satisfaction to be able to do that, as well as be able to learn from that experience and then move on and apply it to other things.
Sounds exciting indeed. May I ask which of your recent research projects with C2MCI you are the most proud of?
Wow, it's like picking a favorite child, but
Exactly.
I'll put it under the big umbrella, which is working with these NHC-functionalized Au13 nanoclusters. We have a variety of them. Some include some targeting with ligands or peptides. Some include just the backbone carbon or gold nanoclusters. But it's exciting because right now I'm working with trying to apply them in an in vivo model and trying to see if we can improve radiation therapy outcome in mice once we apply these clusters. So that's definitely been something that's been really exciting, because not only do you get to kind of have this new exciting drug, but you get to apply it in an animal and see if it can improve the outcome of treating cancer treatment. And I think what makes it really special is the people I get to work with. I get to work with amazing HQPs across the C2MCI platform. And every single conversation I have with them, I learn something new, and I'm able to apply that not only to the project, but onto my own journey as a PhD student. And I think that's what really makes it special.
Fantastic. You mentioned people you're working with, and I know that you have a fantastic team at Toronto. Can you share the time when you really enjoyed working as a part of the team?
Absolutely. I think so. With these clusters comes a lot of different aspects of working with them. There's teams that work with determining the photophysical outcomes of these clusters. There are teams that just make the cluster itself. And in our lab, I'm very lucky that we have postdocs who know how to apply these and how to improve outcomes, either in biological settings with radiation or with photodynamic therapy. So we have the cluster, the 0061 cluster, which I've been trying to apply and working with. And this cluster has shown amazing potential for photodynamic therapy. But since being new to this field, I didn't really know how I can take it in mice. And with the people around in our lab, with their specialties, I was able to really take that cluster in, apply it in mice, and learn along from our postdocs, both on the biological and the chemistry side, and be able to get this cool PTT experiment going, which I believe just would not have been possible without teamwork and without being able to learn from them. And that's just, I think, one instance, but every single day, there's some form of just working with the Zheng lab as a form of a team that just makes the PhD so like just so much better and easier.
Got it. So you mentioned learning from more experienced people in your lab. Have you ever mentored to train someone, and what did you learn from that experience?
For sure. So towards the end of my master's in my previous lab, I actually had two undergraduate students that I was training on and kind of allowing them to pick up the two projects I was working on. And so definitely it was good to kind of lead them through teaching them the background of the project, the protocols, the experiments, all the science that comes with it. But I think what I learned the most from that was my communication got so much better. I think when you're so deep into the project, you overlook little details which you think are not important to explain because it's just like you just know it at the back of your hand. But when you're teaching it to somebody new, it's really interesting just how many little details are important that you might be overlooking. It also, of course, taught me patience as well, which I think any teacher, any mentor, I think that's very important to learn. And as well as I think it just really deepens your own understanding of your project. You have to know it in deep enough detail that you're able to impart that knowledge onto the next person. And it just really forces you to take on that understanding and that approach.
Thanks for sharing that. Speaking about explaining your research to someone, how usually you do explain your research to people totally outside the field you are working in, so like total strangers?
Absolutely. So I think I have a lot of experience with this because my partner, he's not at all from the field. So whenever I'm trying to explain what I'm doing every single day, I do really have to get creative. And I think the way I look at it is I tell him that we use gold nanoclusters almost like a magnifying glass, where like, if you put a magnifying glass under a sunlight, it can cause a small fire and it's like amplifying the heat of the sunlight. So when you have a gold nanocluster and you put a radiation beam on it, it will amplify its effects. May that be in a cancer cell, in a tissue, or in animals. And so that's how I explain that to him. And if we have targeting, I like to use like a lock and key approach that the cells have the right lock, but your drug has to have the right key to be able to bind to the lock and have the impact that you're looking for. So I do have to get creative, but it just helps kind of place those little things in detail. And now he remembers those things because it's like, oh, lock and key means targeting, or amplify, like a magnifying glass. Oh, that means radio sensitization.
Okay. So basically keywords, something familiar people can build their knowledge on.
Absolutely. Yeah.
I'll probably use this strategy myself. So definitely thanks for sharing that. Speaking about
course.
being creative, one occasion when you may need to get creative is when you need to juggle multiple projects or like facing several deadlines approaching. So how do you prioritize tasks in this situation?
That's definitely a skill you learn as you go through a PhD. I live by my calendar. I plan my life at least a week or 2 weeks in advance, depending on the type of project and what's happening. And what I like to do is I know 2 weeks in advance what I will be doing ahead of time. And of course, if things change, that's where the creativity has to come and you have to learn to accept things will change. Sometimes the clusters are not here in time, or sometimes the instrument is not working and you can't do an experiment and you have to reassess. But I find that having a plan in your head, but also staying flexible enough that should the plan change, you can make modifications as you need to, is definitely what helps me kind of meet the multiple projects and juggling them, but also meeting deadlines. I also like to be graceful to myself and taking breaks whenever I need to, because I find if I'm just tired and doing things over and over, I feel like it's just, I'm going to make a mistake and I'm just going to increase my work for the next 2 weeks or the next coming week. But it's definitely a skill that I've been, I think, learning since undergrad. I'm trying to hone it in. And it's hard. It's because every time I feel like you always add more on your plate. It never feels like you're taking things off your plate. I think as you get busier and busier. So definitely is always challenging. But I feel like if you have a structure in place that works for you, may that be reminders, may that be Outlook calendar, reminders, it definitely is something that like helps me push through.
100% on your side. I'm great fond of having structure and planning myself. Unfortunately, like in the lab, quite often not everything goes as planned. So can you share the time when you faced a tricky problem in the lab and go beyond what was planned?
Absolutely. I find that the last 2 months of my PhD recently have kind of felt like it's been part of that tricky problem where nothing I have touched has been working. And that's what really forces you to pull back and just reassess everything that's happening. So we're working with these nanoclusters to apply them in a new platform of X-ray mediated photodynamic therapy. And it's brand new. It's something we're trying for the first time. And every single week you try something new, it wasn't working. You go back to the drawing board because you don't know what didn't work because it's your first time doing it, or you don't know what's going to work. So it's every single week, it's kind of like I'm going into it not knowing what's going to happen. We find out on Friday and then we reassess and we start again on Monday. And that's definitely quite challenging because you just kind of have to stay elastic. You can't put yourself in a box, but you also need to be reasonable and rational into what you are trying to do. Luckily, I do have the people in the lab who can provide the support and expertise to at least have conversations with me that trigger my curiosity, that guide me in the right direction to answer the right questions. But that's definitely been a tricky time in the lab recently where we're trying to navigate through this challenge. So yeah.
One of the questions that we typically ask our guests, what's one piece of advice you'd give to someone just starting their journey in chemistry?
Wow. There's a lot of things I would like to share, but I think the very first thing I would say is you do not need to have everything figured out. I did not know I was going to do a PhD. I didn't know that I was going to switch fields just after undergrad. I have a chemistry background and I went completely molecular biology for my master's. And then I went back again in this mixed medium of both in the Zheng lab where we have the chemistry aspect, but we also have the biology aspect. So I would say that to not feel the pressure at 18 or 20 to figure things out, just allow yourself to have the experiences that call your name at that time. And then I promise you, one way or the other, the puzzle pieces will fit together in a way when you wouldn't have expected them to. Just go through and collect experiences that mean something to you. And as you go over time, you build the right knowledge, you will build the right connections to help you be where you need to be. I think, especially in academia, it is a very independent learning. Yes, it's important to have good team and good communication with them. But at the end of the day, you're leading your project and you do need to have that initiative in your own to be able to take on a project and lead it. Ask the right questions, find the right people, but that all has to come from you. And I think that's a very different skill set you need than just finishing an undergraduate degree where it's mostly exams. So if you're trying to segue into academia, I highly suggest finding different ways to work on little things that allow you to build your independence and answering the questions that are important to you. And yeah, and also lastly, trust yourself. I promise you, like you will figure, none of us knew where we were heading and we have found a way. So I promise you, you will also find a way that works for you.
Sounds fantastic. Thank you very much, Hetvi.
Thank you.
Thank you again, Hetvi. This interview is part of the pilot phase of the C2MCI HQP Highlight Series, and we plan to continue showcasing the outstanding work and experiences of our trainees in future episodes. For this pilot, Hetvi joined us as a featured guest. But beginning with the next episode, however, she'll be stepping into the role of host of the video series. We'd like to thank her not only for sharing her own story today, but also for taking on this exciting new role. We look forward to conversations she'll be leading in the episodes ahead. To learn more about C2MCI and step up to date on future HQP highlights, be sure to follow our LinkedIn page and our other communication channels. Thank you for watching, and we'll see you next time.